Hello everyone, good evening. So today we have a session on determinants. Okay, so just wait for 1-2 minutes and then we'll start. Okay, just wait, some more students will join and then I'll start. Okay, let's start. So this is your first question. So if omega is a cube root of unity, then basically what will be the value of this particular determinant we have to find. Okay, so see how you can find it quickly. So the values are 1 plus I plus omega square, and the third one is omega square, 1 minus I minus 1, omega square minus 1, and similarly minus I minus 1 plus omega minus 1 and minus 1. So I think you guys can clearly see that we can't simply just start expanding it. इसके expansion करेंगे तो हो सकता है काफी लेंदी जाएगा वो, right? So first of all what we'll do, we'll try to simplify this determinant. ठीक है, वो आप कैसे कर सकते हो? How you can simplify this determinant? So using row and column operations. ठीक है, तो आप यहाँ पर रो एंड कॉलम ऑपरेशंस अगर अप्लाई करेंगे, सो बेसिकली व्हाट यू कैन डू, यू कैन सिंप्लीफाई. सो देखो यहाँ पर क्विकली सभी लोग और बताओ कि कौन सा ऑपरेशन यहाँ पर लगाना सही होगा. प्लीज सी दिस एंड टेल मी विच ऑपरेशन यू विल अप्लाई ओवर हियर. यस, so you see, if here I have 1 plus omega square, यहाँ पर omega square, and here I have 1. So if I add row 1 and row 2, so here you will get row 1 and row 3, you'll get 1 plus omega square, right? यहाँ पर आएगा 1 minus 1 will get cancelled, so this will become omega square minus I, and basically this will become minus I minus 1. Okay, so what I can apply over here, or instead of that, what we can do, if I add my row 1 and row 3. ओके, यहाँ पर अगर मैं रो 1 और रो 3 को गाइज ऐड कर देता हूँ, ओके, एंड इफ आई subtract row 2 from it, okay, basically if I apply this particular operation over here, ध्यान से देखना, that is r1 is equals to r1 plus r3 minus r2. तो देखो यहाँ पर 1 माइनस आयोटा है, यहाँ 1 माइनस आयोटा कैंसिल, इन दोनों को ऐड करोगे तो ओमेगा स्क्वायर माइनस 1, ओमेगा स्क्वायर माइनस 1 से कैंसिल, और यहाँ पर इन दोनों एलिमेंट्स को अगर आप ऐड करोगे सो आई माइनस आई कैंसिल्ड, ओमेगा स्क्वायर प्लस ओमेगा, that will be, okay, so let's do this. So I think first one you can clearly see it will become 0, omega square r1 plus r3, so omega square minus 1, omega square minus 1, 0. Now let's see what will be this second element. So that will be this plus this, so minus I plus I will be gone, and you will get this 1, and minus 1 is also gone, so it is becoming omega square plus omega. Okay, and other rows will be as it is, that is your second row will be as it is, and the third row will be also as it is, that is minus iota plus omega minus 1 and minus 1. Now what is omega square plus omega? What is omega square plus omega? That is minus 1, राइट, और माइनस 1, और यहाँ पर हम क्या कर रहे हैं, माइनस R2 भी कर रहे हैं ना, तो क्या आपको दिख रहा है ये एलिमेंट भी 0 हो जाएगा, बिकॉज दिस इज माइनस 1 ना, आई हैव ऑलरेडी ओनली अप्लाइड दिस R1 प्लस R3 इस एलिमेंट में, और अब माइनस 1 प्लस 1 करेंगे तो क्या ये एलिमेंट भी 0 हो जाएगा. सो वी कैन क्लियरली सी जस्ट आफ्टर अप्लाइंग this one operation, that is R1 plus R3 minus R2, all the three elements of first row are becoming 0. So if all the elements of a row are 0, value of determinant is simply equals to 0, right? So here the correct answer will be option number A. ओके, सिंपली यहाँ पर थोड़ा सा आपको टाइम लगेगा, आपको सोचना है कि विच ऑफ द ऑपरेशंस विल बी गुड simplified, will make the determinant value simple, right? So we can simply see if we add r1 and r3, then these two elements are simply getting cancelled very easily, and this second one is also getting cancelled using the properties of omega, that is 1 plus omega square is equal to 0, right? Property of cube roots of unity. Okay, I hope this is clear. Very easy question, right? Okay, let's move to our next question. All right, so this is your next question. The parameter on which the value of determinant, this determinant does not depend upon is. So basically you have to see that on which particular parameter the value of this determinant is not depending. Okay, so here in the first row you have 1 a square, and then you have trigonometric function. So here you have cos of p minus d of x, cos px, cos p plus dx, sin p minus d of x, sin px, and sin p plus dx. So again, what we'll do, we'll apply some operations to simplify this determinant value, right? You can't simply expand it because it will be very lengthy, right? तो यहाँ पर आपको I think clearly trigonometric identities guys use करना होगा. So if you see this function cos of p minus dx, so here can I apply cos of a minus b, right? So cos of a minus b apply करेंगे तो कितना हो जाएगा, cos a cos b plus sin a sin b, right? यही फॉर्मूला होता है cos a minus cos b का, cos of a minus b का cos a cos b plus sin a sin b. So this particular element, right, this will become something like this. Okay, and this, if I look at this particular element, that is cos of p plus dx, p plus d of x, again here applying cos of a plus b, px plus dx है ना, तो cos of a plus b लगाएंगे तो ये कितना आ जाएगा, cos a cos b minus sin a sin b, right? So applying property of your simple formulas of cos a minus b and cos of a plus b. So do squaring row 2 and row 3 and add. Okay, all right Divya, all right, we'll do that also. First see this, okay, I'll explain your point also. So this is what we are getting, right? तो अब यहाँ पर अगर मैं इन दोनों और ऐसे ही सेम गाइज आप sin p minus d of x and sin p plus dx, इसमें भी आप सेम फॉर्मूला लगा सकते हो, राइट? तो sin of p minus d of x, this will become equal to sin a cos b minus cos a sin b. Okay, and similarly sin of p plus d of x, that will become equals to sin a cos b plus cos a sin b. Now if I add row 1 and row 2, okay, sorry, column 1 and column 2, if I apply this operation, that is c1 equals to c1 plus c3, this will become 1 plus a square. Can you see this plus this? So इन दोनों को add करेंगे तो क्या आपको दिख रहा है, sin term will get cancelled, right? It will become 2 times cos of px cos of dx, right? And here it will be simply a, it will be a square, this will be cos px, and this will be cos p plus dx. Similarly, if you add this and this, minus cos px plus cos px sin dx, this term will get cancelled, and here you will get 2 sin px cos dx, right? And here you have sin px and sin p plus d of x. ठीक है, तो इतना सिंप्लीफिकेशन तो यहाँ पर हो गया. अब इसके आगे क्या कर सकते हैं हम लोग? इतना करने के बाद क्या हम इसे और फर्दर सिंप्लीफाई कर सकते हैं क्या? क्विकली सी, कैन वी सिंप्लीफाई इट फर्दर? यहां से अब क्या करें? तो क्या आपको दिख रहा है कि ये जो दो यहाँ पर कॉलम्स हैं, दैट इज C1 एंड C2. लुक एट दीज टू कॉलम्स गाइस, C1 एंड C2. यहाँ 2 cos px cos dx है, यहाँ cos px है, यहाँ 2 sin px cos dx है, और यहाँ sin px है. तो अगर मैं कॉलम 2 में 2 cos dx का मल्टीप्लीकेशन कर देता हूं, right? If I multiply 2 cos px, sorry, 2 cos dx in this column, that is C1, C2, and subtract it from C1, that is this operation. C1 equals to C1 minus 2 cos dx C2. So can you see this particular element will become 0, है ना? 2 cos px dx, यहाँ भी 2 cos px dx आ जाएगा, cos dx. So this will be 0, this will be also 0. यहाँ पर एक element आएगा, that will be 1 plus a square minus 2a cos dx. Okay, and all other elements will be as it is. So now this is what we do to simplify our determinants, right? We try to make either full row equals to 0 or any two elements of that particular determinant to be 0. So here I have two elements 0. Now what I can do, I can expand this determinant along the first column. So अगर first column के along guys आप expand करोगे, so can you see you'll get cos px into sin of p plus dx minus sin px into cos of p plus dx. तो क्या ये आपको sin a cos b माइनस कॉस ए साइन बी टाइप का दिख रहा है एक्सप्रेशन, राइट? साइन ए कॉस बी माइनस कॉस ए साइन बी, सो दैट विल बी साइन ऑफ ए minus b. So if you simplify, px will be gone, it is simply coming out to be sin dx, and this element is coming out to be 1 plus a square minus 2a cos dx. ठीक है, ये एलिमेंट क्या आ रहा है? 1 plus a square minus cos dx. So now you can clearly see we are not get, this is the value of determinant, right? So you can clearly see we have d over here, x भी है, a भी है, but there is no p. Okay, so here the correct answer will be option number second, b. ठीक है, करेक्ट आंसर क्या हो जाएगा यहाँ पर? ऑप्शन नंबर बी. ऑलराइट, सो दिस वाज अ गुड क्वेश्चन, है ना? यहाँ पर बट आई थिंक काफी क्लियरली दिख रहा है कि आपको यहाँ पर ट्रिग्नोमेट्रिक फॉर्मूलेस गाइस अप्लाई करने होंगे. इसमें टाइम इसलिए लगा क्योंकि ये मैंने पूरा लिख के आपको बताया. अदरवाइज यू कैन डू दिस सिंपल कैलकुलेशन इन योर माइंड. सिंपली आप ऐड कर दो तो आपको डायरेक्टली दिखना चाहिए कि दिस प्लस दिस विल बी सिंपली 2 sin px cos dx. ठीक है, ऑलराइट. अदरवाइज आप यहाँ पर cos c plus cos d भी लगा सकते थे, बट मैंने उसको पूरा एक्सपैंड करके आपको बता दिया, किसी को अगर याद नहीं हो तो. ऑलराइट, अदरवाइज यू कैन डायरेक्टली दिस डू दिस कैलकुलेशन, और उसके बाद एक सिंपल सा ये ऑपरेशन और अप्लाई करना. ओके, इज दिस क्वेश्चन क्लियर टू एवरीवन? एनी डाउट्स? So in so guys, there is a very important discussion. So in determinants you can apply row and column operations, है ना? हम ऐसा नहीं कर सकते कि अपनी मर्जी से कुछ स्क्वायर कर दिया और कुछ सब्ट्रैक्ट कर दिया. ओके, यहाँ पर हम ऐसा नहीं कर सकते कि सेकेंड रो को स्क्वायरिंग कर दो और थर्ड रो को स्क्वायर कर दो. ठीक है, ऐसा कोई ऑपरेशन हम लोग नहीं परफॉर्म कर सकते यहाँ पर, राइट? So you can apply operations by adding or multiplying, adding multiple of some row, some column. That kind of operations are valid, but you can't just simply square any particular row or column. वो हम नहीं कर सकते. Any doubts in this question? Okay. All right, let's move to the next one. Okay, so very easy question. Quickly tell me its value. You have 2 minutes. फटाफट जरा इसका वैल्यू बताइए. If f of x is equals to this particular determinant, what will be the value of f of 100? Okay, so here what we will do, so you can clearly see that from the second row, I can take x common, right? From the second row, you can take x common because x is multiplied with all the three elements. In the third row, you can take x into x minus 1 common, right? X into x minus 1 common ले सकते हैं यहाँ से, right? So if I take out these elements, that is x from the second row and x into x minus 1 from the third row. So this determinant will become, this function will become x into x minus 1, 1 x plus 1, row 1 will be as it is. Second row will simply become 2x minus 1 x plus 1, and third row will become 3 x minus 2 and x plus 1. Now you can see from the column 3 also I can take x plus 1 because all the terms x plus 1 is common in all the 3 elements, right? So x plus 1 I can take common from here. So this will become x square into x minus 1 into x plus 1, 1, 2, 3, x minus 1, x minus 2, 1, 1, 1. Okay, this is your fs. Now you can clearly see this determinant is very simple to solve. Okay, so you can perform operation to make two zeros over here, or you can directly expand it also. Directly भी इसे expand कर सकते हो, बहुत बड़ा नहीं आने वाला है. So let's directly expand it. So 1 into x minus 1 minus x minus 2. So I hope you can clearly see that will be 1 minus x into 2 minus 3, that will be minus 1, plus 1 into 2x minus 4 minus 3x plus 3, right? 2x minus 4, this will be 2x minus 4, let me write it. And 2 into x minus 2, that will be 2x minus 4 minus 3x minus 3. So if you simplify it, it will be 2x minus 3x, that is minus x, and minus 4 plus 3, that will be minus 1. So this is becoming 1 plus x, and this is minus x minus 1. So can you see the value of determinant is coming equals to 0. So now value of this determinant is equals to 0. You can clearly see that f of x is also equal to 0. Okay, so irrespective of x, fx is always equals to 0. So f of 100 will be also equals to 0. Okay, यहाँ पर f of 100 का वैल्यू भी कितना आ जाएगा बेटा, that will be also equal to 0. Okay, any doubts in this? Right, very easy question, and these kind of questions are very common, like advanced में तो अब नहीं आते, but mains basically these type of questions are very common in mains examination where you have to simplify the determinant basically. वो आप कुछ common लो, कुछ row column operation करो. All right, so these type of questions are very common. Okay, let's see question on solving system of linear equations. Okay, that is Cramer's rule, very important topic. So if you ask me, from determinants, two topics are very important, that is Cramer's rule and basically properties of determinant, simplifying a determinant. ये दो ही concepts हैं जो बहुत ज्यादा important है. So these two are very important. So let's do this question that is based on properties of Cramer's rule. So here what is given, if system of equation, so you have three linear equations, right, has a non-zero solution, that is x minus kx minus z equals to 0, kx minus y minus z equals to 0, and x plus y minus z equals to 0. So can you tell me which kind of equation these three are, which kind of equations? Like ये linear तो है, लेकिन क्या आप इसको further कुछ और बोल सकते हैं? These are which kind of linear equations? Basically, yes, correct. Homogeneous linear equations. Right, what are homogeneous linear equations? Where the constant term is 0, right? Simply ax plus by plus cz equals to 0. These kind of equations are homogeneous equations. So these three are homogeneous equations, and we want the value of k so that this system has a non-zero solution. Now I hope all of you know this. So basically for homogeneous now, there is only, because you can clearly see delta x, delta y and delta z. These three will be always 0 for homogeneous I'm talking. इसको आपने डेल्टा 1, डेल्टा 2, डेल्टा 3 ऐसे भी पढ़ा हो सकता है कई बच्चों ने, ठीक है, एक ही बात है. I hope you are getting what I am trying to tell. So these values are always 0 because यहाँ constant 0. So the only thing on which our nature of solution depends is delta. Okay, सिर्फ डेल्टा पे ही डिपेंड करेगा कि हमारे इक्वेशंस का सॉल्यूशन कैसे होने वाला है. All right, so now if delta comes non equals to 0 na, all right, then you have a trivial solution, right? If delta comes not equals to 0, then you will have a trivial solution, that is 0 comma 0 comma 0, right? And if delta is equals to 0, then you say you have non-trivial solution, or basically infinite solutions. So here in this case you can clearly see we want a non-zero solution. तो हमें ये condition नहीं चाहिए क्योंकि यहाँ तो zero solution आ रहे हैं ना सारे. So we want this condition. For this condition delta should be equals to 0. थोड़ा सा मैंने explain कर दिया. I hope सबका रिवाइज हो जाएगा क्विकली, राइट? तो कॉन्सेप्ट तो इतना ऐसा था कि अगर आपको याद है तो आप सिंपली गाइस डेल्टा को 0 कर दो. तो डेल्टा क्या आ रहा है? 1 माइनस दिस वाज y, सॉरी y, राइट? सो डेल्टा इज 1 माइनस k माइनस 1, k minus 1 minus 1, 1 1 minus 1. We want this to be equal to 0. So I think we can apply simple this operation, that is c1 equals to c1 plus c3, because two terms are directly becoming equal to 0. Okay, now you can expand along the first column. So that will be k minus 1 into minus k into minus 1, that is k, and minus 1 that will be plus 1. Okay, so k minus 1 into k plus 1, and a minus sign also over here, right? Because it is a to 1 na? So there will be a minus sign also. So this to, for this to be equals to 0, values of k are 1 and minus 1, which is option number D, right? Okay, correct. So D option will be the correct answer over here. Good. So again, very important kind of questions, right? Very basic, but आपको इस type का questions mains as well as advanced में मिल सकता है बहुत easily. Mains में तो बहुत ज्यादा chances है. हम लोग देखेंगे क्वेश्चंस प्रीवियस ईयर भी बहुत आए हुए हैं. संडेज क्लास विल सी. और एडवांस में भी बहुत आसानी से आ सकता है इसका क्वेश्चन. ओके, सो क्रैमर्स रूल इज वेरी इंपॉर्टेंट. ऑलराइट, लेट्स मूव टू द नेक्स्ट क्वेश्चन. ओके, so if omega is minus 1 by 2 plus iota root 3 by 2, that is cube root of unity, then what will be the value of this determinant? Again, very simple. So tell me what will be the value of this particular determinant? So for this kind of question, there is no particular method, right? You can solve it by using any of the method, like you can apply any of the transformations. तो यहाँ पर अब देखो क्या कर सकते हो guys. So we know that if omega is cube root of unity, omega cube is 1, right? So here I can write this omega 2 to the power 4 as simply omega. Okay, and there is one more property, that 1 plus omega square is 0. So can you see I can write this minus 1 minus omega square, minus 1 minus omega square as simply omega, right? So this determinant will become 1 1 1 1 omega square, 1 omega square, and this omega 2 to the power 4 is omega. So now what you can do, if I simply apply this operation, that is c1 equals to c1 plus c2 plus c3. So that will 1 plus 1 plus 1 3, 1 plus omega square 0, 1 plus omega square 0. These will be as it is. Okay, now you can expand it along the first column. So that will be 3 into omega square minus omega square into omega square, that is omega to the power 4, or you can say simply omega. So correct answer is 3 into omega into omega minus 1. So B is correct, right? B option is correct. हाँ, यहाँ पर D अगर आपने correct click कर दिया, क्योंकि only the difference is minus sign, so you'll lose 5 marks basically, और 4 marks, plus 3 minus 1 हो जाएगा. तो 4 marks आप बहुत सिंपली सिर्फ माइनस साइन के चलते यहाँ पर वेस्ट कर सकते हो. कैलकुलेशन पार्ट का इस बहुत ही इंपॉर्टेंट है, वो आपका खराब नहीं होना चाहिए. क्वेश्चन बहुत ही इजी था, सिंपल प्रॉपर्टी अप्लाई करना है और कुछ नहीं. एनी डाउट? ओके, let's see. All right, so this is your next question. The number of values of k for which the system of equations so has infinitely many solutions. Okay, has infinitely many solutions. So can you see this is a linear equation in two variables only. There is no term of z ना, तो ये तो सिंपली लीनियर इक्वेशन इन टू वेरिएबल्स है. तो लीनियर इक्वेशन इन टू वेरिएबल्स के इनफाइनाइट सॉल्यूशन कब होते हैं गाइस? So basically we want infinite solution, and you can clearly see these two are linear equation in two variable, that will be straight lines. So when both the straight lines are coincident, then you will have infinite solution. So for coincident lines, what is the condition? Ratio of constants should be equal. A1 upon A2 equals to B1 upon B2 equals to C1 upon C2, right? This is the condition. ये condition होती है, तो simply आप वो condition यहाँ पर apply कर सकते हैं. Okay, all ratios to be equal, yes, right? Ratio of coefficient should be equal. Now you can solve this. So if you multiply and solve, this will be k plus 1 into k plus 3 equal to 8k. So that will be k square plus 4k plus 3 equal to 8k. So this is becoming k square minus 4k plus 3 equals to 0. And doing factors, we are getting k minus 3 into k minus 1 to be equals to 0. That means from here we are getting two values, 3 and 1. But we have to also check that these two should also become equal. तो यहाँ इन्हें अगर सॉल्व करें, you can simply put the values of k also, क्योंकि ये दो values आई हैं. So that will be 8 upon 6. If I put k equals to 3, the first value will be 8 upon 6, that will be 4 upon 3. And here it will be 12 upon 9 minus 1, that is 8. So that's coming out to be 3 by 2. So for k equal to 3, these two are not coming equal. Na? So this cannot be your answer. For k equal to 1, this will be 8 by 4, that is 2, equal to 4 upon 3 minus 1, that is 2 equals to 2. So yes, correct answer will be k equal to 1. So there is one value. What you have to find? Number of values of k. Okay. So here the number of values of k is only 1. ठीक है. कई बार आप सिंपली बच्चे क्या करते हैं, 3 और 1 दो वैल्यूज आया, दो पे क्लिक कर दिया. नहीं, you have to also check that the third ratio should also become equal, because if these two are equal then they can also be parallel lines ना. No solution की condition भी आ जाएगी वहां तो. So if you want infinite solution, all the three should be equal. So that is, we are getting only for one value of k, that is k equal to 1. Any doubt on this? Okay, let's see next question. Okay, so this is the next question. Solve this question, everyone. If the system of equations x plus ay equals to 0 and az plus y equals to 0 and ax plus z equals to 0 has infinite solution, then what will be the value of a? Quickly solve this. So the equations are x plus ay. I can write this as 0z equals to 0. There is no term of z, so I can write it as 0z. Right. For the next one, az plus y. So that will become 0x plus y plus az equals to 0. And the third one, you can write it as ax plus 0 equals to 0. So for these three equations, we can see we have homogeneous equations now. So this will delta is equal to 0. Okay. So again, delta, that will be 1a0 a0. This should be equal to 0. So directly let's expand. So there should be 1 into minus a square. 0 into 0 will be 0. That's equals to 0. So we're getting 1 plus a cube equal to 0. So that is giving you answer as a cube equal to minus 1. So a equal to minus 1, right? A equal to, for a equal to minus 1, we will get solutions, infinite solutions for this particular system of equation. So a is the correct answer. Okay. यहाँ पर बस गाइस प्लस माइनस की ही अगर आपकी गलती हुई तो आप मार्क्स लूज कर सकते हो. अगर आपने 1 मार्क कर दिया यहाँ पे इसे 1 माइनस ए क्यूब अगर आ गया गलती से, देन यू लूज योर मार्क्स. सो कैलकुलेशन अगेन इज वेरी इंपॉर्टेंट, क्योंकि डिटर्मिनेंट्स में होता है हम कहीं पे माइनस भूल जाते हैं, कहीं पर प्लस भूल जाते हैं, तो वो आप थोड़ा केयरफुली करिएगा. ओके. सो अगेन यू कैन सी वेरी सिंपल क्वेश्चन, जस्ट यू हैव टू रिमेंबर द कॉन्सेप्ट. ओके. सो फॉर इनफाइनाइट सॉल्यूशन यू विल हैव delta equals to 0 for homogeneous. Correct. Okay. All right. Let's solve this one. Given 2x minus y plus 2z equals to 2, x minus 2y plus z equal to minus 4, x plus y plus lambda z equals to 4. Then the value of lambda such that the given equation has no solution. Okay. So you have to find value of lambda such that this system has no solution. So check करो फटाफट. Solve it guys. So you must be thinking कि आज questions बहुत easy हैं advanced session में भी, because determinant से कुछ questions अभी आएंगे अच्छे भी, but to be honest determinant से question उतने ज़्यादा difficult आते भी नहीं है advanced, even in advance also. Okay. Because there are limited concepts. Yes, so let's write down first. So here the equations are non-homogeneous. हाँ, तो non-homogeneous की conditions आपको याद होनी चाहिए. So these are the three non-homogeneous equations, right? Linear equations, and we want value of lambda such that it will have no solution. So for no solution, what is the condition? Delta should be equals to 0, right? Delta should be equals to 0, and at least one of the delta x, delta y, and delta z, this should be not equals to 0. At least one of them, right? At least one of these should not be equals to 0. So first let's calculate for lambda equals to 0. We are getting 2 minus 1 2, 1 minus 2 1, 1 1 lambda. Okay. So let's simply expand it. Okay. That will be 2 into minus 2 lambda minus 1 minus minus plus 1 into lambda minus 1 plus 2 into 1 plus 2, that will be 3. So it's minus 4 lambda minus 2 plus lambda minus 1 plus 6. So this is coming out to be minus 3 lambda minus 3 plus 6, that is plus 3 equals to 0. So we're getting lambda equals to 1. Lambda equal to 1 आ रहा है यहाँ पे. and for this we are getting lambda equals to 0. Now you have to check basically that at least one of these should not be equals to 0. Okay, so let me simply calculate delta z over here. So delta z will be, I'll simply replace this row with 2 minus 4 4. That will be 2 1 1 minus 1 minus 2 1 2 minus 4 4, right? ये जस्ट चेक करने के लिए आप लोग कर रहे हैं. आई थिंक ये आ जाना चाहिए यहाँ पर. एटलीस्ट वन ऑफ देम विल कम इक्वल्स टू 0, राइट? बिकॉज नो अदर ऑप्शन इज, बिकॉज यू आर गेटिंग ओनली वन वैल्यू ऑफ लैम्डा, और ऑप्शन में ऐसा भी नहीं गिवन है कि नो रियल वैल्यू ऑफ लैम्डा. तो आंसर तो 1 होगा. बी ऑप्शन विल बी द करेक्ट, बट फिर भी आप चेक कर सकते हो एक बार. तो यहाँ पर क्या ये नॉन जीरो आ रहा है? -8 + 4, दैट विल बी -4 + 1 into 4 minus 4 0 plus 2 into 1 plus 2, that will be 3. So -8 + 6, this is coming not equals to 0. That means yes, I will have no solution for lambda equal to 1, because delta will be 0 and delta z is not coming equals to 0. अगर ये तीनों भी इक्वल टू 0 हो जाएंगे तो क्या कंडीशन होगी गाइस? मैंने ये कंडीशन क्यों लिखी, दैट एटलीस्ट वन ऑफ देम शुड बी नॉन जीरो. If all of them become equals to 0, तो क्या होगा? Tell me in the chat box quickly. If delta x, delta y, delta z and delta, all of them become equals to 0, yes, then you will have. क्या हमेशा ऐसा होता है? क्या हमेशा ही इनफाइनाइट सॉल्यूशन मिलते हैं जब ये चारों 0 होते हैं गाइस? Yes or no? Please reply with a yes or no. Do you get always infinite solution when all these 4 are equals to 0? देखो, जो भी आपको अभी तक पता है वो आप बताओ, यस या नो. ठीक है, मैं आंसर तो बताऊंगा ही कि क्या सही है और उसका रीजन क्या है, बट आपको अभी तक जो भी पता है, क्या आपको यही पता है कि हमेशा चार जब 0 है तो नो सॉल्यूशन होगा, या सॉरी, हमेशा जब ये चारों 0 है तो इनफाइनाइट हमेशा होगा या हमेशा नहीं? हाँ, वेरी गुड, वेरी गुड. तो कुछ लोगों को याद है, गुड निश्चय. सो गाइज, देयर इज वन कंडीशन दैट यहाँ पर ऑलवेज इनफाइनाइट सॉल्यूशन हो ऐसा जरूरी नहीं है. देयर इज वन केस दैट इज ऑफ पैरेलल प्लेन्स. मैं थोड़ा सा यहाँ पर कॉन्सेप्ट भी बता रहा हूँ क्योंकि आई थिंक सबको चलेगा. देखो, ये इक्वेशंस क्या है गाइस? These are nothing but planes ना, ax plus by plus cz equals to z. So general equation of plane. तो इसका मतलब these three equations are nothing but you can say these three are planes. So when I'll have three parallel planes, तो उस केस में भी तो एक भी सॉल्यूशन नहीं है because they are not intersecting at all. But when planes are parallel ना, तब भी आपको ये चारों डेल्टा 0 मिलेंगे. Delta will also become equals to 0, and if planes are parallel, ये तीनों भी equal to 0 आएंगे. तो उस केस में आपको देखना होगा कि ये डेल्टा, डेल्टा एक्स, डेल्टा जेड, डेल्टा वाई, ऑल ऑफ देम आर 0, बट then also you are not getting infinite solution, you are getting no solution. Why? Because these three are parallel planes. तो हमेशा आपको चेक करना होता है, you have to double check whenever all four are coming equal to 0. आप डायरेक्टली infinite नहीं बोलते हैं, you have to check whether कहीं planes parallel तो नहीं है, and if planes are parallel you will say no solution, and if okay, वेरी गुड, याद था आप लोगों को, बहुत अच्छी बात है. जिसे नहीं पता था गाइज, ये याद रखना, वेरी इंपॉर्टेंट कंडीशन है ना. जनरली ये बुक्स में लिखी नहीं होती, मतलब बच्चे भूल जाते हैं इस कंडीशन को. वो सोचते हैं चारों इक्वल टू 0 तो इनफाइनाइट होंगे. नहीं, नो सॉल्यूशन भी आ सकता है फॉर पैरेलल प्लेन्स. ओके, ऑलराइट, काफी डिस्कशन हो गया. लेट्स मूव टू द नेक्स्ट. सो सॉल्व दिस क्वेश्चन. P equals to Aij, it's a matrix, right? And it's a 3 cross 3 matrix, right? P is a 3 cross 3 matrix of Aij, and Q is equals to Bij, where what is Bij? It is 2 to the power I plus j into Aij, when I and j are greater than equals to 1 and less than equals to 3. So if determinant of p is 2, okay, that means this determinant if this determinant is equals to 2, you have to find determinant of this matrix q. So what is matrix q first of all? So q is 2 to the power I plus j aij, right? So for b11 that will be 2 to the power 1 plus 1, 2 square a11, then it will be 2 cube a12, 2 to the power 4 a13. Here it will be 2 cube a21, 2 to the power 4 a22, 2 to the power 5 a23. And here it will be 2 to the power 4 a31, 2 to the power 5, sorry, 2 to the power 5 a32, and 2 to the power 6 a33. Right, this will be your matrix q. Again it will be also 3 cross 3 because I and j both are lying in between 1 and 3, right? So उसकी value 1 2 3 ही हो सकती है. So 3 columns 3. So now simply what you have to do, you have to find determinant of q. आपको इसका determinant find करना है basically, and this determinant value is equals to 2, it is given. So can you simply see, I can take 2 square common from the first row, guys. From the second one I can take 2 cube common, and from the last row I can take 2 to the power 4 common. So after taking these numbers common, I'm getting the determinant of something like this, right? 2 square a13, 2 square a3. ओके, और यहाँ पर गाइज आपको फिर से दिख रहा होगा फ्रॉम कॉलम 2 एंड कॉलम 3 अगेन आई कैन टेक 2 and 2 square common. So यहाँ पर ये कितना आ रहा है 5 plus 4 9, 2 to the power 9 was already out, 2 and 2 square from here, that means 2 cube again outside. And can you see the remaining determinant again will be p only, right? Determinant p, that value is 2. So it is coming out to be 9 plus 3 12 plus 1 13. That is option number D, right? Option number D will be the correct, 2 to the power 13. Yes. Okay, so you can see very easy question based on determinants and very recently 2012 examination, right? 3 mark question. तो सिंपली प्रॉपर्टीज पर बेस्ड आपको क्या लेना था, यहाँ पर कॉमन लेना था. ओके, आई होप इट्स क्लियर टू एवरीवन. Okay, all right. Now guys, let's solve some MCQ. Okay, so this question is an MCQ question. Okay, solve this question, guys. A alpha plus B C B alpha plus C, A alpha plus B alpha plus C, and 0. So if this value of this determinant is equals to 0, then you have to see which of the options are correct. A, B, C, D, and here we have a E option also. So just tell me in the comment. Okay, I think it will be difficult for you to write. क्या operation यहाँ पर लगा सकते हैं? Which operation you can apply? Just see. So I think you can clearly see A alpha plus B alpha plus C. So what we can do, we can multiply the first column with alpha, add it with C2, and then subtract from C3. Right. So basically this particular operation, let me write here. C3 equals to C3 minus alpha C1 plus C2. Right. C3 minus alpha C1 plus C2. Okay. So You can clearly see A alpha plus B, A alpha plus B, that will be 0, 0. This will be little bit difficult. It will be A alpha square plus B alpha, right? A into alpha into this plus B alpha plus C. So that will be A alpha square plus 2B alpha plus C with a minus sign. So 0 minus this, that will be minus A alpha square plus 2B alpha plus C. Other two will be as it is. Other two columns, right? Yeah, as it is आ जाएंगे और अब आप क्या करो guys? Expand it along the third column. So that will be C33. So with the positive sign. So that will be minus A alpha square plus 2B alpha plus C into AC minus B square. Okay, so this is equals to 0. So either this can be equal to 0 or this can be equal to 0. So A alpha square plus 2B alpha plus C, this equals to 0, or AC minus B square equal to 0, or you can say B square equal to AC. So you can clearly see this is the condition of GP. So this will be 0 if ABC are in GP, and if alpha is a root of this particular, no, not this particular equation. If x minus alpha is a factor, yeah, E option. So A, B and E are the correct, right? B and E. B and x minus alpha is a factor. That means x is equal to alpha will be a root of this equation. So हाँ वो भी correct है because this term will become 0 then, right? So B and E are the correct options over here. So simply what we are doing, applying column transformation over here. All right. Let's move to the next one. If value of this particular determinant is equals to y, E and not D, because in okay, because in D there is B alpha beta, यहाँ पर bx apart, there is no 2bx, right? We were getting 2b alpha na, so that's why D is not correct. Okay, all right. What about this one? A very easy question. If this is equals to x plus iota y, what will be the value of x and y? So I think what you can do, you can apply this operation first. That is R1 equal to R1 plus R2, right? Why? Because this 1 minus 1 0 minus 3i plus 3i will become 0. So 0 0 6 iota 4 3 iota minus 1 23 iota. Expand along the first row. So that will be 6 iota into 3 iota square, that is minus 3 and plus 3. Okay, so it's coming equal to 0. Correct answer will be D option. Oh, very easy question. Right. The value of determinant is simply coming equal to 0, right? So x and y both should be equals to 0. Let's solve next one. This was very easy. Can we multiply C2 with I, okay, and subtract from C3? हाँ वो कर सकते हैं बिल्कुल. You can do that. You can multiply with I and subtract from C3. Yeah, you can do that. I don't know whether it will help or not, but you can do that. वो operation valid है. The operation is valid. Okay. So you can multiply anything with row or column and subtract or add with any particular row or column. Okay. But you can't simply like just multiply anything or take a square. Okay. These kind of operation are not valid. Row column operations apply कर सकते. Yeah. Okay. This question. दिस वाज अ गुड क्वेश्चन, ये एक अच्छा क्वेश्चन आया था JEE Advanced 15 में. So try this question, guys, and just tell me if you're getting it, just tell me the concept, how you can find the value of alpha over here. Okay. So first try to see the question, how you will start. Yes, anyone? Just tell me the concept with which you will start solving this. So it's quite the question easy है देखने में, determinant का value इसके equal है and you have to simplify and alpha. But how to simplify this determinant? That's the question, right? Because you can't simply expand it. Okay. So first let's open this square. So that will be 1 plus alpha square plus 2 alpha, right? Then 1 plus 4 alpha square plus 4 alpha. Guys, correct me if anywhere I do it wrong. Okay, कुछ mistake हो तो बताना है आपको. Alright, I hope this is correct. Then here you will have 4 plus alpha square plus 4 alpha. 4 plus 4 alpha square plus 8 alpha. 4 plus 9 alpha square plus 12 alpha, right? And next one is 9 plus alpha square plus 6 alpha. 9 plus 4 alpha square plus 12 alpha. Okay. 9 plus 9 alpha square plus 18 alpha. I hope this is correct. Yeah. So this is what we are getting. Okay. So all diagonal entries will be equal when we take common 2 from A to 2. That's the thing, na, beta. You can't take a number common from a particular element. You need to take either from the row or from the column. Sorry, this is row, this is column. Yeah. Okay. You can't take any number common or you can multiply anything with a particular element. Okay. That basically operation you need to perform with a row or a column. तो अगर आप टू कॉमन लेना चाहते हो तो या तो पूरी रो से कॉलम लो, सेकंड रो से या सेकंड कॉलम से. You can't just take from A22 or A33. That is not valid. Right? Multiplication of a scalar with a determinant. So या तो आप रो से कॉमन लो या कॉलम से कॉमन लो. तो वो तो यहाँ नहीं कर सकते. उसके अलावा और कुछ? तो आई थिंक कुछ लोग ऐसा सोचेंगे कि यहाँ पर 4 अल्फा स्क्वायर है हर जगह, राइट? एंड हियर यू हैव 9 अल्फा स्क्वायर. So you must be thinking, let's multiply first C1 like C2 minus 4C1 and C3 minus 9C1. तो ये 9 अल्फा स्क्वायर कैंसिल हो जाएगा, बट अल्फा तो फिर भी रहेगा ना. और अल्फा गाइस इतना इजी भी सॉल्व तो नहीं होगा. R2 इक्वल टू 2R2 माइनस R1 माइनस R3. ओके, 2R2 this minus this. ओके, या यू कैन डू दैट. मतलब ये एक ऑपरेशन हम यहाँ पर लगा सकते हैं, उससे थोड़ा सिंप्लीफाई तो होगा. यस, दैट इज 2R2 minus R1 plus R3. So can we apply this particular operation? क्या ये ऑपरेशन हम अप्लाई कर सकते हैं? जस्ट टेल मी दिस. 2r2 minus r1 minus r3. Is it a valid, just tell me, is it a valid transformation? Can we apply this kind of a transformation in determinant? All of you, quickly tell me this. Yes, we can apply. Okay, just reply with a yes or no. 2r2 minus r1 plus r3. बट गाइस क्या आप इस 2 से मल्टीप्लाई कर सकते हो? हाँ, जिस रो में आप ऑपरेशन लगा रहे हो उसी रो में आप किसी कांस्टेंट से मल्टीप्लाई कर सकते हो. बेसिकली इसको आप ऐसा सोचो ना, इफ यू आर मल्टीप्लाइंग 2 विद रो 2, r1 plus r3 is fine, but this 2 is not fine. Here you can do 2r1 plus r3. क्यों? बिकॉज उस रो में चेंज नहीं हो रहा है कुछ भी. बट अगर इस रो में आप चेंज करना चाह रहे हो 2 से मल्टीप्लाई, सो उसके बाद लिए पहले आपको आप ऐसा कर सकते हो कि 2 से मल्टीप्लाई और 2 से डिवाइड करो, बट जस्ट यू कांट अप्लाई दिस ऑपरेशन ना. या दैट्स व्हाट आई एम टेलिंग. अगर आपको ये ऑपरेशन लगाना है तो आप क्या करो कि आप 1/2 ऐसा बोल दो ना कि मैंने 2 से मल्टीप्लाई कर दिया रो 2 को, बट ये 2 एक बाहर फिर लेना पड़ेगा. And then you can apply this, basically that then it will be simply r2 equals to r2 minus 2 r1 plus r3. Okay, but this you can't apply. ठीक है, यहाँ पर कोई मल्टीप्लीकेशन नहीं होना चाहिए उस रो का, उस रो में कोई फैक्टर मल्टीप्लाई नहीं हो सकता. ओके, चलिए. तो गाइज लेट मी नाउ टेल यू. सो यस, यू कैन अप्लाई दिस. लेकिन यहाँ पर ना जो सबसे इंपॉर्टेंट चीज है वो ये है गाइज कि बिफोर थिंकिंग दिस, आप जरा इस डिटर्मिनेंट को ध्यान से एक बार देखिए. देयर इज समथिंग स्पेशल अबाउट दिस डिटर्मिनेंट. सो इफ यू लुक एट द टर्म्स, तो क्या आपको दिख रहा है? हियर यू हैव अल्फा स्क्वायर अल्फा स्क्वायर अल्फा स्क्वायर. हियर यू हैव 4 अल्फा स्क्वायर 4 अल्फा स्क्वायर 4 अल्फा स्क्वायर, 9 अल्फा स्क्वायर 9 अल्फा स्क्वायर 9, 149 149 149, right? Similar elements, 2 4 2 alpha 4 alpha 6 alpha, then 4 alpha 8 alpha 12 alpha 6 alpha 12 alpha 18 alpha, in proportional these numbers are same. So I don't know how many of you know this, but मैंने I think आप लोगों को पढ़ाया था, मैंने determinants पढ़ाया था. So I told you about a concept called as multiplication of two determinants, right? Anyone remembers this? So I told you, whenever you have this symmetric kind of expressions ना, एक symmetric यहाँ पर आपको दिख रहा है कि तीनों में 149 कॉमन है. This alpha square term is common in all the three. This 2 alpha 4 alpha 6 alpha, you can see these are proportional, so this term is also common in all the three. So whenever you have common elements in all the three rows or columns, you have to think about this multiplication of two determinants concept. What is this concept? So basically, when we multiply matrices, there is a particular order, right? Row by column. But if you want to multiply two determinants, beta, you can do any method like row by column, column by row, row by row, and column by column. All kinds of multiplications are possible. Okay. So here this determinant is nothing but it's multiplication of two determinants. Okay. So how to then write down in form of multiplication of two determinants? So let's use row by column because uski hame aadat hai. We use that in matrices also. So here if you see, if I want first term of multiplication to be this 1 alpha square 2 alpha, ठीक है, और second मुझे चाहिए 1 4 alpha square, here it will be 4 alpha plus 4 alpha, and 1 9 alpha square 6 alpha square. So one thing is pretty sure that this term is common in all the three, 1 alpha square alpha. So here if I make the first row as 1 1 and 2, can you see? I'll get the first element. Yeah, it's multiple correct. Yeah, it's multiple correct. So I'll get 1 into alpha square into 2 alpha, first element. If I take my second column as 1 4 4, तो क्या आपको दिख रहा है मुझे ये second element मिल जाएगा this into this. And if I take my third row to be 1 9 and 6, can you see? I'll get my third element. ऐसी अगर यहाँ पर मैं second element सेकेंड रो को गाइज ये ले लेता हूं, दैट इज 4 1 and 2, sorry, not 4 1 and 2. Basically if I take this as 4 alpha square and 2 alpha, so can you see I'll get the first element, that is 4 into 1 4 alpha square into 1 alpha square, 2 alpha into 2 is 4 alpha. Then this into this, 4 into 1 is 4, alpha square into 4 is 4 alpha square, 2 alpha into 4, that will be 8 alpha, 4 into 1 is 4, alpha square into 9 is 9 alpha square, 2 alpha into 6 is 12 alpha. Great, I am getting the same thing. And if I take my third row, tell me quickly what should be the third row so that I'll get these three elements on multiplication with these three columns. यहाँ पर third row क्या होना चाहिए? तो first element तो I think 9 होना चाहिए because you are getting 9 common. Then alpha square, right? And this element should be 3 alpha. So this particular determinant is multiplication of these two determinants. Okay. ऑलराइट, यहाँ पर ये कॉन्सेप्ट हमने यूज किया कि इस डिटर्मिनेंट को हमने ब्रेक कर लिया टू डिटर्मिनेंट्स के मल्टीप्लिकेशन की फॉर्म में. ओके, अब आप गाइस यहाँ पर देखोगे, सो वी कैन फर्दर सिंप्लीफाई इट. आई कैन टेक अल्फा स्क्वायर एंड अल्फा कॉमन फ्रॉम हियर, सो अल्फा क्यूब विल कम आउटसाइड. ओके, एंड दिस विल बी 149 111 123 multiplied with, so I hope you know this property, if you interchange all the rows into columns, the value of determinant remains same, right? तो यहाँ पर मैंने सारी rows को सारे column में change कर दिया. And if I take 2 common from here guys, अगर मैं 2 4 6 है तो 2 common ले सकता हूँ मैं यहाँ से, so it will become 1 2 3 and 1 2 will come outside. And if I interchange these two, on interchanging two rows or two column, you will get a minus sign. और क्या आपको दिख रहा है, फिर ये दोनों determinant same हो जाएंगे. So I'll get square of basically this particular determinant. So it is minus 2 alpha cube into multiplication into square of this particular determinant. और इसका वैल्यू गाइस आप बहुत इजीली फाइंड कर सकते हो. ओके, इसका वैल्यू आप बहुत इजीली फाइंड कर सकते हो. दैट विल बी सिंपली, लेट्स एक्सपैंड इट. So 12 minus 18, that will be minus 6, minus 1 into 3 minus 2 1, plus 1 into 9 minus 4, that is 5. So it is coming minus 7 plus 5, that is minus 2. So minus 2 alpha cube into minus 2, that will be 4 alpha cube equal to minus 648 alpha. So alpha will be, okay, I am getting a minus sign over here. So basically if you cancel with 4, it will be 1 8, no 1 and 4 6 yeah. Guys, please see if I'm making any mistake because the value is not coming. अच्छा, स्क्वायर भी करना है, सॉरी हाँ हाँ, yes, I have to square it also na. So minus 2 square will be 4, so minus 2 alpha cube into 4, that will be minus 8 alpha cube. So this value is minus 8 alpha cube, which is equal to minus 648 alpha. So minus minus plus, alpha is gone. So if you divide with this, we are getting it at 681. So alpha is square equal to 81. That means alpha is equal to plus minus 9. Right? So answer is B and C. Okay. So this concept is multiplication of determinant. So if you use this concept, this question will be very easy. Kritika, which method you used? Use this method only or any other method? Same, yeah. Okay, good. See, because this question is based on this method, और आप में से कुछ लोगों को लग रहा होगा कि सर how it will click. So basically जब ये पढ़ाया जाता है तब ये, because this is a standard question, whenever you see similar terms in all the three rows and column na, then it should click. Yeah, you can split it in different ways, the answer will come exactly same. Okay, answer will come exactly same because just you have to split it into multiplication of two determinants. That's the concept. Okay, so from now on guys, this is also an important concept. Remember this, whenever you see sub, first of all it should be addition of three terms. right? Because when you multiply you'll get three terms ना, तो हमेशा addition of three terms होना चाहिए and similar kind of terms in all rows and columns. So here the similar kind of terms were 149, 149, 149, alpha square, alpha square, alpha square, alpha, 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 alpha. So that's why I guessed it that okay, I can break it into multiplication operator. Okay. All right. Good. All right. Let's solve this question now. This is MCQ again. So let a lambda mu, all of these belongs to real number. Consider the system of linear equation. So basically this is linear equation in two variables. So very simple. So which of the following are correct? I think you can answer this one. Solve this one, guys. I want answers from everyone. Okay. So let's start one by one, right? So if a is equal to -3, then the system has infinitely many solution for all values of lambda and mu. So let's see if this option is correct. So for infinite solution, the condition is ratio of coefficients should be equal, na? So this is the condition for infinite solution. So here in the option it is given for all values of lambda and mu. If a is equal to -3. So if a is equal to -3, this will be -1, -1. But no, for all values of lambda and mu, it will be correct? No. Let's suppose if lambda is 3, mu is 2, then it will become parallel lines. Na? So there you will guess no solution. So A option is incorrect. Okay, what about B? So if A is not equal to -3, okay, then system has unique solution for all lambda and mu. So if lambda is not equal to -3, yes, then you will get this a upon 3 will not be equal to -1. तो अगर ये equal नहीं है -3 के, then yes, for all values of lambda and mu, whatever be this lambda and mu, this will give you a unique solution. I hope you know this condition. तीन condition होती है guys, let me write that. For unique solution, this is from your 10th standard, right? Exactly from your 10th standard. So if a1 upon a2 is not equal to b1 upon b2, then you'll get unique solution. Basically intersecting lines, right? You are making slopes to be non-equal. This is the condition. That's why we get this condition. Then you have no solution. So for no solution, we say line should be parallel. So if they are parallel, a1 upon a2 should be equal to b1 upon b2, but this should not be equal to c1 upon c2. And the third one is that is infinite solution, where we want coincident lines. All right. So for that, all the three ratios should be equal, right? So B is correct. What about C? Lambda plus, if lambda plus mu is equals to 0, then system has infinitely many solution for a equal to -3. Yes, because a if -3, this will be -1, -1. And if lambda plus mu is 0, lambda will be equal to minus mu, that is also -1. So yes, B, C is also correct. If lambda plus mu is not equal to 0, okay, then system has no solution for a equal to -1. Again correct. these two will become equal, but this third one will be not equal, so it will be no solution. So B, C, and D. So can you see, guys, JEE Advanced 2016, you got a question based on 10th standard, right? And the MCQ, so it will be +4. Okay, so B, C, D is the correct answer. So, so you have to remember, basically this is the approach which we use in Cramer's rule. Cramer's rule के जो result है वो यही इन्हीं expression से आए हैं, but वो अभी आपको नहीं बता सकते डिटेल में. तो आपको ये conditions याद रखनी है when you have two lines and sorry, when you have two variables, and for three variables you can simply use Cramer's rule. Okay. All right. Let's see next one. Okay, so in teacher one, total number of distinct x for which this determinant value is equal to 10. Yes. So how to solve this one? So I think you can clearly see I can take x and x square common, right, from this one. So that will be x into x square, that will be x cube. X cube will come common. 1, 2, 3, 1, 4, 9. Here it is 1 plus x cube, 1 plus 8x cube, 1 plus 27x cube. So I hope you remember this property, again a very important one. We can break this particular determinant into two determinants, right guys? That will be, one determinant will be simply this one plus this determinant, right? So you should remember all the properties. कोई भी property use हो सकती है कहीं भी, right? I hope you remember this property. If you have any row or column as sum of two elements, you can break that into two determinants. Now this determinant value you can find simply. Here I can take x cube common. Okay, so this x cube will be multiplied with both the determinant. So x cube into this determinant, let's calculate its value. So that will be 1 into 4 minus 9, that is minus 5, minus 1 into 2 minus 3, that is minus 1, plus 1 into 18 minus 12, that is 6. So minus 1 plus 1 plus 6, that is coming out to be 2. Okay, and let's solve this also. That is 1, 2, 3, 1, 4, 9, 1, 8, 27. So here I can take 2 and 3 common from these two. Na? So 6, 1, 1, 1, 1, 2, 4, and 1, 3, 9. Okay. So if I interchange these two and again interchange these two, can you see it will be the same determinant exactly? है ना, पहले C1 C2 को इंटरचेंज किया, फिर C2 C3. So माइनस माइनस प्लस साइन भी हो गया और ये वैल्यू डिटर्मिनेंट तो सेम आ गया 2. So this value of determinant will be 6 into 2, that is 12. Okay, and multiplied with the x cube which you take common from this particular column. So it will be 2 plus 12 x cube into x cube equals to 10. Okay, so if I assume x cube as t, this will be t into, right, t into 12t plus 2 equal to 10. So that is t into 60 plus 1 is 5. So it is coming out to be 60 square plus t minus 5 equal to 0. So I think t equal to minus 1 is one of the root, that is t plus 1 will be one factor and this will be the one factor. right? So t equal to -1 and t equal to 5/6. What is t? T is x cube. So x cube equal to -1 and x cube equal to 5/6. So how many distinct x you are getting? So here we are getting real. Okay, we want real. So x equal to -1 and one value from here, that is cube root of 5/6. So basically two distinct values of x we are getting, right? So the correct answer will be 2. Okay, so simple application of your this particular. Okay, yeah. Just a second. Yes, Kritika.
So if we add these two determinants normally, like we would do, won't we get two extra? Like 1 plus 1 will become 2, and then 2 plus 2 will become 4.
No, no. But that you can't do, na. You can't simply add all the rows and column. That is not how you add two determinants. Okay, either you add any two particular rows or any two particular column. That's it. You can't add all the elements of, like, you won't add these two rows, these two columns, then these two columns, then these two columns. Okay, you have to do it only along one particular row or column. Okay, if you want to add two determinants, then you can add elements of only one row or only one column. Okay, is it clear? Yeah, let me.
So what I was asking is
Yeah,
the everything was adding, is that in matrix?
yeah. Then if that was in matrix, then you have to add all the particular elements
Okay, in determinants only one row or one column, and
or
in
one column. Yeah,
all.
yeah,
Okay, okay.
yeah. So these properties of matrix and determinants you have to remember. Same with goes with like multiplication of a scalar also. In matrix, if you multiply a scalar, it gets multiplied with all the elements. But if you multiply a scalar with determinant, you either have to multiply with a row or a column. That can be any column or row ना. तो वैसे ये प्रॉपर्टी भी है कि आप किसी भी पर्टिकुलर एक रो या एक कॉलम के एलिमेंट्स को ऐड कर सकते हो when you are adding two determinants. That's up to you. So here we are using that particular property. Sir, see my question. Sir, will cube root of 5/6 be real? 5/6 का क्यूब रूट तो रियल ही होगा ना. 5/6 का क्यूब रूट नॉन रियल क्यों होगा? 5/6 इज अ रियल नंबर ना, और उसका क्यूब रूट भी रियल होगा, राइट? इंटीजर नहीं होगा. यू डोंट वांट इट टू बी इंटीजर, यू वांट इट टू बी अ रियल नंबर. तो रियल नंबर तो 5/6 अगर रियल है तो उसका क्यूब रूट भी रियल होगा, राइट? इंटीजर नहीं होगा ना. हाँ, ओके. आई थिंक लास्ट क्वेश्चन है. या लेट्स सॉल्व द लास्ट क्वेश्चन. Let omega be the complex number cos 2 pi by 3 plus iota sin 2 pi by 3. That is your cube root of unity, right? Then number of distinct complex number z satisfying this particular relation, that this determinant is equals to 0. Okay, so check this question out, try to solve. So you can guys remember this thing. आपको कई बार क्वेश्चन में ऐसे भी कंफ्यूज होता है, लाइक इफ ओमेगा इज गिवन टू यू, आपको अपने आप से नहीं मानना है दैट इट इज अ क्यूब रूट ऑफ यूनिटी. It will be given every time in JEE. Every single time they will mention if omega is a cube root of unity or not. जैसे हमने क्वेश्चंस देखे वहां पर डायरेक्टली लिखा था if omega is a cube root of unity. Here they have given this relation. So you can clearly see cos 2 pi by 3 plus iota sin 2 pi by 3. That is nothing but our cube root of unity na, e to the power iota 2 pi by 3. बट इफ इट इज नॉट गिवन, अगर ये टर्म यहाँ नहीं गिवन होता और इस टाइप का एक्सप्रेशन होता, तो आपको ये नहीं मानना है कि ओमेगा इज अ क्यूब रूट ऑफ यूनिटी. समटाइम्स ऐसी मिस्टेक हो जाती है स्टूडेंट्स से. So it will be mentioned every time. Same goes with like your GIF function also, or fractional part. Every single time they will mention if this kind of brackets are given, अगर वो GIF है, they will mention in the exam, okay, that it is a GIF or your fractional part. If it is not given, don't assume it. Like general discussion. So here it is given that it's a, so now it's a cube root of unity. This is equals to 0 and this omega cube is equal to 1. These two are very important relation. So can you simply operation C1 equal to C1 plus, this will become right 1 plus omega is become Z plus 1 plus, this will also become Z plus, sorry. So can you see these terms will be omega square. If you add these, I can take it common, so Z will come outside. 1 omega Z plus omega square 1 omega square 1 Z plus omega. So you can now apply this particular operation, that is two operations simultaneously. That is R2 equals to R2 minus R1 and R3 equal to R3 minus R1. Okay, I am directly applying two operations in one time. Okay, so just see what will be R2 minus R1. What will be R2 minus R1? So R1 basically will be as it is. Right, we are doing change in R2 and R3 only. So 1 minus 1 0. Z plus omega square minus omega 1 minus omega square. Here also it is 0. 1 minus omega Z plus omega minus omega square. So now if you expand along the first column, sorry, this will be 1 into Z plus omega minus omega square and Z plus omega square minus omega and multiplied with this. Okay, so it is coming little bit complicated. Can we do anything else? कुछ और कर सकते हैं क्या guys यहाँ पर? Okay, let's do this only.
So if you just expand this, the one you wrote at the bottom, then most of the terms cancel out.
Okay, by simply expanding it, yeah, that I think. Okay, yeah, let's do that, because after applying this, basically this is getting complicated. Yeah, so let's just simply expand it. So this will be 1 into Z plus omega square into Z plus omega, Z plus omega square into Z plus omega minus 1, then minus omega into Z plus omega minus 1. Okay, and plus omega square into 1 minus Z minus omega square. Okay, so this will become Z square plus omega square Z plus Z omega plus omega cube minus 1, that will be 0, right? So this is from the first term, minus Z omega minus omega square plus omega from the second, and omega square minus Z omega square minus omega to the power 4, that will be only minus omega. So now let's see, Z omega square is getting cancelled, Z omega also getting cancelled, omega minus omega, omega square minus omega square. So we are simply getting value of this determinant as Z square. So Z square into Z, that is Z cube, equal to 0. So z cube equals to 0. That means the only solution we are getting is z equals to 0. So number of distinct complex number z satisfying this equals to 0 is equal to 1. Right? You'll say 1 is the correct answer, right? Because z equals to 0 is the only solution. So there is only one complex number z which will satisfy this particular relation. Any doubts in this?
Sir, I had a question.
Okay.
Like for instance, in this question only, z cube comes 1. So now our answer is going to be 3 as 2 cube roots of unity and 1 is 1.
Z cube equals to 1. Yeah, if in this question the answer will be 3 because you have to calculate complex numbers, right? Complex number z. So here the answer will be 3. But if like if x cube, if in other question x cube comes equals to 1, so basically if you don't have to calculate like imaginary value, then answer will be 1. Okay. But in this question you have to count complex numbers. So yeah, that will be equals to 3 because again we will have 3 roots, 3, 1 real and 2 complex roots, right?
Got it, sir.
So for this, yeah. All right, guys, then I think that's it for today. Okay, so we have solved some good questions. So in the next class, that will be on Sunday, we'll solve some mains level problem. Okay, and you're getting some good questions from Cramer's rule and properties in mains also. Okay, so we'll discuss that problems on Sunday's class. Okay. All right, guys, then. Thank you. Bye.